Hi, Mr. Richards here. Today's lesson 6.5 is on discount and markup. Let's go over a few key definitions first, with the first one being markup. Now, markup is the amount the price of an item is increased above the price that the store paid for the item. Imagine that you have a new Blu-ray disc, and it costs $10 for the store to purchase that. Well, then they're going to turn around and sell it to you for $15. Well, the amount of markup there would be $5. It's the amount the price of an item is increased above the price that the store paid for the item. Now, with this goes the definition of selling price. And this one is actually no tricks about it. This is just simply the amount a customer pays for an item. So the selling price would be the $15 there. The next definition is discount. When you think discount, you can think of sales, because discount is the amount by which the regular price of an item is reduced. In this lesson, we're going to be working with percentages to calculate markups, new selling prices, and discounts. In our first example, we are going to find the selling price. So find the selling price if a store pays $68 for a portable DVD player and the markup is 35%. Now we're going to use our percent equation on these questions. So remember, our percent equation was part equals our percent times the whole. Now, there are two methods here, and the first method is to find the amount of markup first. So, our markup here is going to be the part. That's the part. So we can say that's going to be M, and that's going to equal our percentage, which 35% as a decimal is decimal 0.35 or 35 hundredths. And we're going to multiply that by 68. And 35 hundredths times 68 is $23.80. So our amount of markup was $23.80. Now we're looking for the selling price. We have to take our original price of $68 and add the markup amount of $23.80 to get our new total of $91.80. So in method 1, we're going to use our percent equation. We're going to look for the markup amount, which is our part, by taking our percentage as a decimal, multiplying it by our amount, and we'll get a price. Now that's not our final answer, that's the amount of markup, so we have to add it back to figure out our selling price. Now, our answer is $91.80. But we can use another method to find this, and that's method 2, where we find the total percent first. We can still use the percent equation, but first, if we take 100% of the price, we know that's going to be $68. And if we add the markup percentage to that, 35%, that means our selling price is going to be 135% of the price the store paid. So if we use our percent equation, where our part is going to equal our percent times our whole again, we can say, okay, our part is going to equal my percentage, which 135% as a decimal is 1.35, as you have to move your decimal point over twice, times the price the store paid, which was $68. And when you multiply 1 35/100ths by 68, you get $91.80. So again, in this method, we'll add the 100%, which represents the $68, the 35%, which represents our markup, to say, okay, our selling price is going to be 135% of the price the store paid. We can use our percent equation. Our percent times that whole amount will get us a total of $91.80. So 2 methods for you to use on how to find selling prices. Now what if we want to find a sale price? So we're going the other way. We're going to be using some subtraction here. A baseball mitt has an original price of $89. It is on sale for 25% off the original price. Find the sale price of the mitt. And again, we can use our percent equation, which was part equals percent times our whole. And our part here is going to be our amount of discount. So we can say, okay, my discount is going to equal 25%, which as a decimal is decimal point 25, multiplied by my $89. When I multiply these two together, I get my total discount of $22.25. So that's how much you're saving. Now to find our new price, our sale price, we can take our $89 and subtract our $22.25. Do some old-fashioned borrowing here. Who needs a calculator? Our answer is $66.75. Now, just like in the first example, we do have a second method where we can find the total percent first. Now, in the first example, we added, since we were dealing with markup, but here we're dealing with a discount. So our original price of $89, that represents 100% of the cost. Now, I'm taking 25% off. So I can subtract 25% to get 75%. Now that 75% represents the sale price. I'm only paying 75% of the original price. So once again, I can use my equation where I'm going to say, okay, my sale price is going to equal 75% as a decimal, decimal point 75. Multiply that by the $89, and I end up with, once again, $66.75. So again, 2 methods, you get to pick which you like. Both involve the percent equation. In one, you're finding the discount and subtracting from the original price. In the other, you're doing your subtraction first to say, okay, I'm paying 75%. What is that? And you're calculating it right in your equation. 2 methods, you get to decide which you like best. A restaurant rolled back prices for a day to their 1964 prices. A pizza that usually sells for $8.50 was marked down 90%. What was the 1964 price of the pizza? Well, before we set anything up here, if the price was marked down 90% to get to the 1964 price, what we need to do is first take 100% and subtract the 90% to get 10%. Now that 10% represents the 1964 price. And we've been using the equation so far, but this question we can actually use the percent proportion, where you have part over whole equals your percent over 100. But in this question, your part is actually going to be your 1964 price, while your whole is your current price. And the percentage is actually going to equal your 1964%, which in this case was your 10%, your 1964 percentage. So as we then make these substitutions in, your part is actually going to be X, because we're looking for the 1964 price, over the $8.50 that we're currently paying for that pizza. We're going to set that equal to 10 for the 10% over 100. Now, before I solve this, remember this is your X, which is your 1964 price. The 10% represents the amount you're paying compared to today. So you're only paying 10% of what you would be paying today. Your $8.50 is today's price, and that's 100%. So as I go to cross multiply these, I'm left with 100 times X equals $8.50 times 10. So 100X equals 85. And I can finish this question then by solving for X. So divide by 100 on both sides. And X is going to equal 0.85, or just 85 cents. Not bad for a slice of pizza, let alone a whole pizza. Jamie bought a television that was discounted by 33% during a sale. The regular price was $599. She paid a sales tax of 7.75 or 7.75%. How much did she pay for the television? Well, there's two steps here, and our first step is going to be to find the discounted price. Now, if the amount of the discount is 33%, then the discounted price is going to be 100% minus the 33%. So our discounted price is actually going to be 67% of the regular price. So we need to find 67% of $599. So we can say, all right, my discount is going to equal 0.67, 67% as the decimal, times $599. So my discount is going to be $401.33. So that is my discounted price. Then I have to add my sales tax. Now, we can once again use the percent equation, and the method we're going to use here is to say, okay, my new discounted price is 100% plus my sales tax of 7.75%. So my price after I add the sales tax is going to be 107.75%. That's going to be the new price. So after my tax, my new price is going to be, now get that percentage into a decimal, which is 1.0775, because remember you have to move your decimal place over twice, so it's 1.0775, which is 1 775 10,000ths, but then multiply that by the $401.33. After you multiply those together, you get $432 $4.43. So as we review this question, we first found the discounted price by saying that's going to be 67% of the original price. So 67% times $5.99 got me the $401.33. Then I added the 7.75% sales tax, multiplied, and got my final answer. That's it for this lesson. Good luck.